Hello everyone, welcome back. So this time we're going to be going over how things connect when it comes to pressure. Now, let me get my head out of the way. Go up here. Okay, so we know you have the pressure equation. It's pressure equals force over area. And force is going to be how things usually connect. Area will typically be given to you in the problem statement, or pressure will be. So if you have a force, what's it going to look like? Well, one common way is that it will be a weight. They'll give you a weight, mass times gravity, or they'll give you a mass that you can calculate a weight to determine force. That's usually, they say, like, what's the pressure something exerts on a table, on the ground. It's always something that's underneath it. It's an object like this, sitting on something. That exerts a pressure on the surface it's sitting on because of weight. A second example would be if you have multiple forces. You get a bunch of forces here, force 1, force 2, force 3, force 4. You have to add them all up. We don't do that too much in this class, but it will be something you're going to do in future classes, so keep it in mind. Now, gas pressure, it's a very long equation. It's got a lot of stuff in there, but if you look at the gas pressure equation, there's only a few ways that it usually connects. One could be through number of moles. You might be given a certain mass, and you have to use that to calculate the number of moles, and then you can calculate pressure. So that could work. Another way would be through temperature. Temperature might change. It might change a pressure or a volume, causing things to move around. Volume is typically provided, and one thing to remember is that there's a whole lot of ways that this can be made a lot simpler on you. Just use your head. Really simply use your head. Like, if something halves in size, its volume is decreased by half. If everything else is constant, its pressure should double. If it's a tenth of the size, its pressure should go up by 10 times. This will help you. Don't forget that. Okay, so what about units? Well, pressure has almost just an obnoxious amount of units. It's painful almost. So your book has conversion factors, and you should always reference them. Just don't try to memorize all these. The one that might be good to remember is that there's 101.325 kilopascals. That's 1,000 pascals, so 1,325 pascals in 1 atmosphere. A pascal is a very small unit of pressure, extremely small. That can help you. You'll see that sometimes in gauge pressure questions, which we don't really go over much in this chapter because it's not super important, but it's in your book, so reference it. Okay, so if you want to convert, just always do what you normally do. Thing you have on top, conversion factor, with the thing you have on bottom as the unit. And you just go straight through. Be very careful in your book because both numbers will likely not be 1 when it comes to pressure. So you'll have one number that will not be, two numbers that will not be 1 in here. Just make sure you put the units in the right place. You can also run into non-standard units. In those cases, you're going to have to remember that pressure is force over area. You have to convert the area units to something that's more common, like PSI or Pascal. So that would be meters squared or inches squared. And the force units to either pound force, not pound mass, pound force, or newtons. Okay, so gone over all this. We're finishing up pressure right now, but don't worry about it. I'm going to do some example problems as well to help you through it. See y'all later. Bye-bye.